binary numbers represent actual values, and then I went through this quick example of adding two binary numbers together. And we're going to combine our knowledge from that last video with logic gates to actually make the circuit that will add two bits together. We're going to start by adding two bits together, then we're going to combine those together to make a circuit that will add two full numbers together. Okay, so how do we do this? Well, let's go through every situation of combination of bits. Let's just say we have a bit A and a bit B, and we're adding them together. Well, they could both be zeros, in which case the sum, S, will obviously be a 0. Okay. One of them could be a 1, and the sum in that case will obviously be a 1. Okay. They could both be 1s, and the sum will be, the sum will be a 0, but there will be a carryout. So I'm going to draw this little CO down here underneath to represent there will be a carryout. Because 1 plus 1 is 2, so the sum is 0, and that bit carries out to the next position, kind of like this situation we saw here. 1 plus 1 is 0, the carry bit goes over to the next most significant bit is how we call it. Okay. Then the other situations are, one of them could be a 1, but there was a carry in from the previous bit. Okay, well, this is kind of just like this situation, where we're just going to get a 0 with a carry out. Now, what happens if both are 0 with a carry in? Well, that's just 1. What happens if both are 1 with a carry in? Now that's 3. So there's actually going to be a 1 for the sum and a carry out, because 3 1s obviously equals 3, which in binary is represented by this. So if you can imagine, if there was a carry in here, which there isn't right now, but just imagine if there was, sorry, I meant to erase this, then this would be a 1, and the carry bit would come over, because we can only represent 0 and 1 with binary. So if we need to represent 3, we have to bring down a 1, and then this 1 is kind of like the 2. It's like 2 plus 1. You know, that's kind of how that works. So now we have kind of laid out all these situations. So the sum bit will be 1 under a couple situations. Well, it looks like it's a 1 whenever A and B have an odd number of 1s, if you've noticed. Here, here, and here we have an odd number of 1s. Well, that's interesting because I introduced a logic gate that's literally the odd function called the XOR gate. So A XOR, which is this symbol, you might have not have seen this before, B XOR our carry in bit, which we'll call Cn. Those will be 1, or the sum will be 1 when this condition is true. Okay, so our carry out will have some formula also. What is that going to be? Well, you can see our carry out is a 1 when both A and B are 1. That's this situation, and it's actually this situation here too. These are both the same situation, because whether or not we have this carry in bit, we're going to have a carry out if A and B are both 1. So A, and the way you denote A and B is just writing, you'll see this or you'll see A dot B. So 2 different notations. And then what else could make the carry out a 1? Well, this situation rather, is a 1. The carry in is a 1, and A is 1 and B is 0. But if A was 0 and B was 1, we'd still get a carry out here, wouldn't we? They're basically the same thing. So if our carry in is a 1 and either of these is a 1, either A or B is a 1, we'll get a carry out. Well, we know what that is. We know that A XOR B will be true if exactly one of them is a 1. If both of them are a 1, we've already covered that here. We've already done this. Okay, so A XOR B and carry in. And I'll put these kind of in parentheses to show that they're different. So if this happens or this happens, we get a carry out. Or is just a plus. Okay, Well, we know what an AND gate is. We know what an OR gate is. We know what an XOR gate is. This is another AND gate. So let's draw all this stuff. So we have A and B, and we need to XOR those to make the sum. And these are going to be XOR'd with our carry-in bit to create our S bit. Okay, C, we'll call it, I've been doing CN, okay, or CI, I should keep it consistent. We'll just call it CI, not CN. Okay, so that creates the sum bit, cool. Carry out, well, we know A and B OR, so there will be some OR gate at the end, actually, or A XOR B and CN. Well, we've already XOR'd A and B here, so we can just take this and AND it with CN, which is this wire, so I guess we can just bring this down here. And then these just go into an OR gate, and that's it. So think about it. We drew out this little algebraic equation, and then we just drew it. C out equals A and B, or A XOR B and C. Sum equals A XOR B XOR CN. And that's it. So this whole thing is a logic circuit that will add 2 bits. Now I can take this and connect a bunch of them together to actually add the full numbers together, and I will show that in